Everyone, myself Rishiraj Dasghosh from second year ECE. So today I am going to show you all a toolbox based on analog communication subject, which which was a subject from Macout. And today I have made a toolbox where I have chosen the topic amplitude modulation from the subject analog communication to showcase the practicality on what we have just studied in the theories. Okay, by seeing the waves, how that actually works and what is actually the message signal and what is the carrier signal and what are the outcomes for amplitude modulation if there is a message signal of having frequency 2.5 gigahertz and amplitude 1.1 and a carrier signal having frequency 33 hertz and amplitude 0.9. So there will be some amplitude modulation and as well as the modulation index concept also we will be showing it to you. And I have just added or modified something in the toolbox, which includes the comparison center, where we will be comparing these two signals, the message signal and carrier signal, based on that amplitude modulation signal, frequency modulation signal, and the power modulation, pulse modulation signal. Okay, so basically this is my toolbox, and just for showcase, I have just created a 3D waveform model type thing which will showcase all the type of signals which I have just created. As you can see, the PM signal, FM signal, AM signal, and the carrier and the message signal. Okay, so without any more delay, let's just start. So the amplitude modulation toolbox includes message signal and carrier signal. As we all know that there are many such modulation type. Right now we are working with the double sideband full carrier signals. Okay, so this is the message signal, and in this message signal we can literally change the frequency of the message signal based on the user and as well as the amplitude of this message signal based on the user what actually wants. And not only the sine waves, the person can want square waves, triangular waves, and sawtooth waves. Okay, so there are various different kinds of waves here also, and these kind of waves differ in amplitude modulation as you guys can see. And let me just slow a bit the frequency because it's very fast, and we can pause the overall thing so that we can get the exact value which we want to calculate. And again we can play, and there are modes also, dark mode and light mode, and this is all. And there is also a concept of modulation index over here, that is under this one is under modulation, this one is mu equals to 1. See, the amplitude modulation changes if we actually put mu is equals to 1 or the modulation equals to 1. And if we do the over modulation, see, there is also a change in the amplitude modulation signal. Okay, so this modulation index also works very well over in the toolbox here, and the frequency spectrum also changes according to the modulation index. Okay, so now going forward to the comparison center. So here also the same thing, there is message signal, the carrier signal, and the same modulation index. But here the only difference is that if we, in the previous slide, in the previous page, we have just seen the change in the amplitude modulation if the modulation index was there. And now in the comparison center, if we change the modulation index, we can see all the three signal types difference: amplitude modulation, FM signal, and PM signal. The difference is very clear. And if we, this is mu equals to 1 value, and if the modulation index is over modulation index, then the graph changes as you guys can see. Okay, so we all can do the modifications over here. And the last, the 3D waveforms which I have just created based on the frequency and the amplitude provided. And see, this one is the message signal, this one is the carrier signal, and this one is the AM signal, the FM signal, and the PM signal. These all things can be modified just as the previous slides. See, the changes are made immediately without any delay. So this was all for the toolbox portion which I have created. Hope you all liked it. Thank you.